Hi everyone, this is Dr. Venkateswarlu, working as a professor of EC at IARE, Hyderabad. Today we will be discussing about time domain analysis of DTS systems, discrete time systems. So here the time domain analysis of discrete time system, to verify these all are contents are discrete time system, mathematical expressions, E operator, response of linear discrete time systems, useful signal operations, response of linear DTS with the discrete time systems, zero input, zero state response, convolution sum, and graphical procedure for the convolution sum with reference to classical solutions of linear difference equations. Okay, from here, so the time domain analysis of discrete time system, in this case DTS system mathematically. So normal cases we are using the DTS, already know that. Based on the DTS mathematical notation, here we have to remember this previous DTS system mathematical expressions with reference to that. We have to use the advanced operator form. So with this, the advanced operator form, it is considered with the y of k plus n plus an minus 1 y of k plus n minus 1 plus and so on, plus a in a1 y of k plus 1 plus a naught y of k is equal to bm. Here the bm f of k plus m plus bm minus 1 f of k plus m minus 1 plus and so on, plus b1 into f of k plus 1 plus b naught into f of k. This is the advanced operator form with reference to the DTS, discrete time system mathematical expression, or we can consider the T equations. So the left hand side of this form consists of the output at instance. Here it is from this. So we have to consider this is the left side. This is the right side. Okay. The left hand side of this form consists of the output at instance. Okay. So that is followed by k plus n minus 1, k plus n minus 2, k plus n minus 3, and so on. As per this advanced operator form, we have to identify the left hand side of this form. We have to recognize k plus n minus 1, k plus n minus 2, and so on. So the right hand side of this equation consists of the input at the instance. Okay, here k plus m minus 1, k plus m minus 2, and so on. Okay, the condition that the above system is causal, if it is casual, is that m less than or equal to small n. With this, okay, so for a general causal case or casual case, you have to consider where m is equal to small m is equal to small n. Okay, this is the case. It is for only general purpose. So we will see that in a special purpose also for implementing this DTS, discrete time system, based on a mathematical expression or equations. So for a general casual case or causal case where m is equal to n. Okay, so within this, m is equal to n. Okay, and the above system can be expressed as, okay, in mathematically, that y of y of k plus n plus a n minus 1, y of k plus n minus 1 plus and so on, plus a1 y of k plus 1 uh, y of k plus 1 plus a naught y of k. It is also equal to that. So where bn of f of k plus k plus n plus what do you call bn minus 1 into f of k plus n minus 1 plus and so on plus b1 into f of k plus 1 plus b naught f of k. Okay, which is this is all the system. The system is based on the discrete time system. Mathematical expression is relevant if it is we will consider either what do you call causal or non-causal. But this case is causal. The system is causal is m less than or equal to n. For this case, for general purpose case, general causal case, for m is equal to n. So the system can be expressed as like this mathematical equation based on this. So we write to verify that delay operator form. The delay operator form based on this particular case. The case is general causal case. In case m is equal to n. We can replace k by k minus n throughout the equation. Such replacement yields the delay operator form. The delay operator form is followed by y of k plus an minus 1 into y of what do you call k minus 1 plus y of k plus an minus 2 y of k minus 2 and so on plus a1 y of k minus n plus 1 plus a naught y of k minus n. It is also equal to that bn f of k plus bn minus 1 f of k plus k minus 1 plus and so on b1 plus b1 into f of k minus n plus 1 plus b naught f of k minus n. Okay, from the delay operator form, with reference to this delay operator form, y of k, it is denoted as what we call y of k plus an minus 1 y of k minus 1 plus and so on plus a1 y of k minus n plus 1 plus a naught y of k minus n is equal to bn f of k plus bn minus 1 into f of k minus 1 and so on plus and so on. We will use that bn f of k plus bn minus 2 f of k minus 2 and so on plus b1 f of k minus n plus 1 plus b naught into f of k minus n. Okay, yeah, it can be expressed as y of k. Maybe that by using this system, the system is DTS, discrete time system. We are considering these all mathematical equations. Based on this, if we are under delay operator form, is in case where small m is equal to small n. It can be expressed as y of k is equal to minus an minus 1 into y of k minus 1 minus an minus 2 into y of k minus 2 minus and so on minus a naught y of k minus n plus bn into f of k plus bn minus 1 f of k minus 1 and so on plus and so on up to plus b naught f of k minus n. That means there are the past n values of the output. Okay, for this y of here it is, we will consider y of k minus 1 y of k minus 1 if it is y of k minus 2 and y of what you call y of k minus, okay, k minus 3, okay, and y of k minus 4, okay, this up to y of k minus n. So as per this, the first n values of the output response, the first n values of the input f of k minus 1, f of k minus 2, f of k minus 3, f of k minus 4, f of k minus 5, and so on, f of k minus n, and the present value of the input f of k. So like this, we will follow this delay operator form in case m is equal to n. We can replace k by k minus n throughout the mathematical representation. We have to verify that first n values of the output, the first n values of the input. That's why we are using the delay operator form if in case m is equal to n. This is nothing but the time domain analysis of discrete time system. Okay, so you can consider these are all nothing but advanced operator form, because of we are following this delay operator form. If it is m is equal to n, of that replacement yield, that delay operator form, we can replace k by k minus n throughout the mathematical equations. So within this, so the first n values of the output, the first n values of the input will be appeared. The present value of the input is f of k. Okay. Yeah, the time domain analysis of discrete time system. So discrete time system equations we have seen right now with based on the initial conditions, general purpose case or general causal case, initial conditions and iterative solutions of the difference equations. If the input is causal, the f of minus 1 is equal to f of minus 2 is equal to, okay, we will identify that now it is varies. So it is also equal to that f of minus n is equal to 0, and we need only an initial condition is y of minus 1, y of minus 2, y of minus 3, y of minus 4, y of minus 5, and y of minus n. Okay, so this results allows us to compute iteratively or recursively the output. We will expect that output response is y of 0, y of 1, y of 2, y of 3, y of 4, y of 4, 5, and so on. For instance, to find the y of 0, we set k equal to 0. How? The left hand side of is y of 0, and the right hand side contains terms as per this previous general causal term where small m is equal to small n. Okay, so with reference to that, the right hand side contains terms y of minus 1, y of minus 2, and so on, y of minus n. And the input value is f of 0, f of minus 1, f of minus 2, f of minus n, and so. Okay, so therefore, with reference to this all notation, okay, so we must know the n initial conditions. Based on these initial conditions, how their conditional iterative solutions of the difference equations, if the input is causal, if the input is a different value, we can do that which one is what you call iteratively or recursively the output response y of 0, y of 1, y of 2, y of 3, and so on. For that purpose, you can find that y of 0, the time we have to substitute k equal to 0. So we must know that n initial conditions. Okay, y of minus 1, y of minus 2, and y of minus n to find y of 0, y of 1, y of 2, y of 3, and so on. Okay, from this time domain analysis of DTS, okay, we have to consider mathematical expressions for that. So initial condition and iterative solution of difference equations. For this case, we have to use the simple what you call example. Solve that iteratively y of k equal minus 0.5 into y of minus k, y of k minus 1 is equal to f of k with initial condition y of minus 1 is equal to 16 and causal input f of k is equal to k2. Okay, this is the given problem example. So how we are solving this type of problems for justifying that time domain analysis of DTS, discrete time system with reference to mathematical expressions. So rewritten this equation in the delay operator form and move all past output to the left. Y of k is equal to 0.5. Like here already is given that where what do you call y of k, that y of k is equal to minus y of k minus 0.5. So y of what do you call k minus 1. It is the given iterative value. Okay, so with this, the rewritten the equation in the delay operator form and move all past output to the left. So here where y of k, where y of k is equal to 0.5 y of what do you call that k minus 1, okay, k minus 1 plus f of k. Okay, so this is the rewritten this given equation, the delay operator form, and move all the past output to the left. So we obtain, with reference to this equation, we obtain y of 0 is equal to, that means that k value is substituted, k value is equal to 0. So here y of 0 equal to 0.5 y of minus 1 f of what do you call f of k, f of k, no, that what do you call 0.5 into 16 plus 0, it's easily can write to calculate that 8. Next y of 1 0.5 y of 0 plus f1, here it is 0 and 1, 0.5 into 8. Okay, because of that y of minus 1 is equal to 8 and so the causal input is f of k. Here it is that y of 1 is equal to 5 and similarly that y of 2 is equal to 0.5 y of 1 plus f of 2 is equal to 0.5 into 5 plus 2 into 2, it is 6.5. Okay, next y of 3, same thing, same procedure, 0.5 y of 2 plus f of 3 is equal to 0.5 into 6.5 plus 3 into 2, 12.25. Okay, so y of 4, where y of 4 is equal to 0.5 y into 3 because of the k value substituted, k equal to 0, 1, 2, 3. Okay, so here it is, here the k value is substituted here, k equal to 3, 3 minus 1, and so on, f of 4. That means 0.5 y of 3 plus f of 4, 0.5 into 12.25 plus 4 into 2. So that is nothing but what you call 22.125. Okay. So like this we will write to verify that time domain analysis of DTS, discrete time system, y of 0 is equal to 0.5 y of minus 1 plus f of 0 is equal to 0.5, 16 plus 8, and y of 1 is equal to 5, and y of t is equal to 6.5, y of 3 is equal to 12.25, and y of 4 is equal to 22.125. Okay, but here it is mathematically we are ready to calculate that where if it is k equal to substituted k equal to 0, 1, 2, k equal to 2, k equal to 3, k equal to 4. We are ready to verify these are numerical values. Okay, from this graphically we should identify that in terms of the time domain analysis of discrete time system. For this, k versus y of k. According to iterative solution of the difference, if k equal to k is substituted initially at the origin k equal to 0, k equal to 1, k equal to 2, k equal to 3, and k equal to 4, 5, 6, and so on. Okay, like this easily can verify that graphical representation for this iterative solution of the difference k versus y of k. Because of that y of k, here that y of k is substituted, where initially that k is substituted k equal to 0, 1, 2, 3, and 4. Okay, like this you like to verify that graphical representation for this time domain analysis of discrete time system with the x-axis the k, y-axis is y of k. The second one, you have a right to verify that solve the iteratively y of k plus 2 minus y of k plus 1 plus 0.24 y of k is equal to f of k plus 2 minus 2 f of k plus 1 with conditions. The condition is y of minus 1 is equal to 2, y of minus 2 is equal to 1, and causal input is f of k is equal to k. So using this all, how they are calculating the iterative values. Same procedure, we return the equation in the delay operator form and move all fast output to the left, where y of k is equal to y of k minus 1 according to given equation. Here it is given that y of k plus 2 is equal to minus y of k plus 1 plus 0.24 y of k is equal to y f of k plus 2 minus 2 f of k plus 1. Okay, rewritten this equation the delay operator form and move all fast output to the left. That is followed by what you call this one, where y of k is equal to y of, so where it is y of k minus 1 minus 0.24 y of into y of k minus 2 plus f of k minus 2 f of k minus 1. So we obtain that what you call y of 0, y of 1, and y of 2, and so on. So y of 0, that k value is substituted here, where k equal to 0, where y of 0 equal to y of minus 1 minus 0.24 y of minus 2 plus f of 0 minus 2 f of minus 1 is, so we have to substitute this, simplify this even, 2 minus 0.24 into 1, 24 into 1 plus 0 minus 0, that means 1.76, and so on. Y of 1 is equal to what do you call y of 0 minus 0.24 y of minus 1 plus f of 1 minus 2 f of 0, and is equal to 1.76 minus 0.24 into 2 plus 1 minus 0, that means 2.28. Likewise, in y of 2 is 1.8576. Okay, like this, right, to verify this all. Now if we are considering the continuous time signal, CTS, or continuous time system, we use the operator D to denote the operation of the differentiation. For a discrete time system, DTS, we use the operator E to denote the operation for advancing the sequence by one time unit. Thus, E of f of k is equal to f of k plus 1. Next level, E square into f of k is equal to f of k plus 2, and so on. If it is e power 3, f of k is equal to f of k plus 3, and so on. E power n f of k. Here, e power n f into f of k is equal to f of k plus n. Yeah, by using this all analysis in the CTS system, we use the operator D to denote the operation of the differentiation. For DTS, we use the E operation for advancing the sequence by 1 unit, or we can consider one time unit, like this E into f of k, or E square into f of k, and so on. Finally, that e power n into f of k is equal to f of k plus n. Okay, so we have to use that in terms of the simple example, y of k plus 1 minus a into y of k is equal to f of k plus 1. Like e into y of k minus a, y of k is equal to e into f of k. Okay, here it is. Okay, here this case e of a into y of k is equal to e into f of k. So like this, we have to use this continuous time signal. Based on that, we require the system. In continuous time system, we use the operator D of its effects, and using this time domain analysis of discrete time system. Based on this DTS, how it is response with reference to this response of the E operator. Okay, that E operator is for instant time system. We use that operator E to denote the operation for the advancing the sequence by one time unit. By using these mathematical equations, easily can write it to verify that response of linear discrete time system, but the response of the system response to what you call internal conditions, how it is varies. With reference to that CTS, continuous time system, we use that operator D, how it is affected with the differentiation for DTS system. That means here easily can analyze that CTS and continuous time system and discrete time system. With the continuous time system, we use the operator D. Okay. If you are using the operator D to denote the operation of the differentiation. For discrete time system, we use the operator E. Yeah, here this case, here the continuous time system, but it is denoted with capital D. In a discrete time system, it is denoted discrete time system. We use that operator, what you call E, capital E, to denote the operation for advancing the sequence by one time unit, like E into f of k is equal to f of k plus 1, E square into f of k is equal to f of k plus 2, and so on. So by using this, it is the time domain analysis of DTS, discrete time system equations, how it is reflects. We'll try to verify that response of linear discrete time system, how it is very the system response to internal condition by using this DTS operator E operator. Okay, so next the T operator with reference to the continuous time system, we use the operator D to denote the operation of the differentiation For a discrete time system, we use the operator E to denote the operation for advancing the sequence by one time unit. Thus, so E into f of k is equal to f of k plus 1. E square into f of k is equal to f of k plus 2. Okay, and so on. Okay, so here it is E in f of k is equal to f of k plus n. For example, we have to analyze that y of k plus 1 and y into k plus ey of k minus e into y is equal to e into f of k, e minus a into y of k into is y of k is equal to e into f of k. Okay, with this, for coming to this second order difference equation, it is represented in equation, mathematical equation, y into k plus 2 plus 1 by 4 into y of k plus 1 plus 1 by 16 into y of k is equal to f of k plus 2. Similarly, e square f of k, e square plus 1 by 4 into e plus 1 by 16 into y of k is equal to e square into f of k. A general nth order, if it are, here we are considering second order difference equation is like this. Yeah, a general nth order difference equation, if it is the general what you call causal system, already we have verified, where m is equal to n. With the second order and coming to the general nth order difference equation, if small n is equal to small m, can be expressed as e power n plus a n minus 1 into e power n minus 1 plus so on a1 into e plus a naught into y of k. It is also equal to this. Okay, the bn into e power n plus bn minus 1 into e power n minus 1 plus so on plus b1 into e plus b naught plus into, it is represented into f of k. That means q of e plus q of e into y of k is equal to the probability p into e of f of k, where q of e is equal to e power n plus a n minus 1 into e power n minus 1 plus so on plus a1 e plus a naught. Coming to this pe into f of k, where p of e is equal to bn e power n, because of already it is assigned according to the first order or second order representation, e power n. If it is, we are considering the general nth order differential equation. If it is n is equal to m plus bn minus 1 into e power n minus 1 plus so on, where plus b1 into e plus b naught. Like this, what are the outcome, what are the analysis of this first second order and general nth order differential equation? It is all analyzed with the time domain analysis of discrete time system with the response of linear discrete time system response to internal conditions, how it is affects by using the particular operator. The operator is followed by E operator. Based on this all operator, second order, how it is affect operator E, and general nth order difference equation, if it is n is equal to small n, can be expressed as like how it is affect internal condition based on the linear discrete time system response to internal condition. E operator will affect like this, Q of E and P of E. For the second order difference equation, so y of k plus 2 plus 14 into y of k. Like this, by using the simple example, easily can analyze that what you call second order and nth order difference equation if it is n equal to m and so on. For this case, easily can verify that the DTS mathematical expression for how it is affect the E operator. Okay, yeah, similar to the continuous time case. Okay, in the previous one is DTS, discrete time, DTS, discrete time system. But we are talking about the time domain analysis with reference to DTS. Based on that, similar to the CTS, continuous, if it is both are, if we have seen that both DTS and CTS, continuous time signal, based on the system, similar to the continuous time case, total response is equal to 0 minus input response plus 0 minus state response. The 0 input response is followed by y naught of k is the solution of the system. With this, f of k is equal to 0, that is q into e into y naught of k is equal to 0. Like this, by using this continuous time case, the total response is equal to 0 minus input response plus 0 minus state response. It will be reflected with y naught of k is the solution of the system. With f of k is equal to 0, that is the q of e y naught into k equal to 0, the time. If it is e power n plus a n minus 1 into e power n minus 1 plus so on plus a1 e plus a naught y naught of k equal to 0. Similar case, y naught, y naught, like here it is, we are right to represent the if how it is affect the q of e and y naught of k is equal to 0. So, but here y naught of k, that y naught of k plus n minus 1 y naught of k plus n minus 1 plus so on a1 y naught k plus 1 a naught y naught k y naught of k equal to 0. With this is can analyze how it is the effects with this operator E. Okay, so the response is you can verify that we will expect that a response of the linear discrete time system, how it is system response to internal condition, that E operator is affected. Okay, so like this, the discrete time system, the E operator, similar to the continuous time case, total response is equal to 0 input response plus 0 state response. Okay, with this, the 0 input response is followed by y naught of k is the solution of the system with the f of k is equal to 0. If not this, if it has total response is equal to 0 plus input response, how it is affect this E operator? It should easily can verify. We will verify in further cases. But if it is the solution of the system with f of k equal to 0, that is okay. The what you call q of e y naught of k equal to 0, or otherwise we will try to verify that en plus an minus 1 en minus 1 plus and so on a1 e plus a naught product of this y naught of k equal to 0. Or we can consider the y naught of k plus 1 y naught of k plus n plus an minus 1 into y naught of k into y naught of k. Okay, that y naught of k plus n minus 1 plus so on plus a1 y naught of a1 into y naught of k plus 1 plus a naught y naught of k equal to 0. So like this easily can observe this all how it is reflect with this what you call that operator T when we are using the time domain analysis of discrete time system. Based on the system response, okay, yeah, the discrete time system equates response of the linear time system response. How it is in internal conditions, the zero input response. So the equation states that the linear combination of the y naught of k and advanced y naught of k is equal to 0. So already we have seen that y naught of k and this is the linear combination. The equation states that the linear combination of the y naught of k and advanced y naught of k. So what is the advanced y naught of k is 0 not for some values of k is equal to 0 not some values of k. K is substituted either 0, 1, 2, 3 and so on. So where y naught of k is 0 not for all some values of k but for all k. Such situation is possible if and only if y naught of k, okay, and advanced y naught of k have the same form. This is true only for the exponential function gamma for k. Since easily can analyze this one with how it is affect with reference to the E operator based on the zero input response, easily can analyze this type of mathematical notation. Okay. So here the equation states that linear combination of y naught of k and this all these values are reflected. Now it is functioning with we have seen that this E naught of k and E2 into what you call E into y naught of k, okay, and E2 y naught of k, how it is reflect, and En and so on, En that En into y naught of k easily can analyze based on this all how it is the equation state that the linear combination of the y naught of k and advanced y naught of k is 0 not for some values of k but for all k. Such situation is possible if and only if y naught of k and advanced y naught of k have the same form. This is true only for an exponential function y of k. So like this, we try to verify that time domain analysis of discrete time system with the zero input response. Okay. So the zero input response is considered in different mathematical equations, how it is varies in time domain and with reference to discrete time system and somewhat the characteristics polynomial of the system will appear. After that we will try to consider the characteristics roots of the what do you call values or eigenvalues is you can verify and analyze by using the time domain analysis of what you call discrete time system with the response of the linear discrete time system. System response will affect with this operator E and the internal condition is based on the zero input response. With this, the exponential values are characteristics modes, or we can consider natural modes of the system will be reflected. Based on that, how it is, where is that response of the linear discrete time system response to internal conditions, maybe E effect and zero input response and so on. Okay, like this, try to verify the time domain analysis of discrete time system with the different mathematical notations, how it is varies. Okay.
Like, share and subscribe. Hit the bell icon for more updates.